And now I'm passing the floor to Patrick Turley, who's the next speaker with a keynote on the topic of problems with using polygenic scores to select embryos. Mr. Turley.
Let me share my screen. Great, so I'm going to talk about problems with using polygenic scores to select embryos. It was discussed a little bit in the first panel in this session, but I'm going to go a little bit deeper into some of the issues involved in using polygenic scores to select embryos. First, just a very, very brief description of what embryo selection using polygenic scores is. So just to start off, polygenic scores are a summary measure of our best guess of a person's risk for some disease or some trait, just based on genes throughout their entire genome. So instead of looking at single gene disorders, these are complex traits that can be affected by genes across the whole genome. And so, for example, there's this paper, Kara et al., where they created a polygenic score for cardiovascular disease, and they looked at the risk of developing cardiovascular disease later in life based on the percentile of your polygenic score. And so they found that people who are in the top percentiles of polygenic risk for cardiovascular disease are 4, even 5 times more likely to develop cardiovascular disease relative to those who are in the bottom percentiles of polygenic risk. This is subject to a lot of caveats, which I'll describe later in the talk. In addition to this polygenic scoring technology that's been developed, there's been technology developed that allows us to genotype embryos. And if we can genotype them, then we can calculate the polygenic scores of embryos as well. And so there have been companies that have emerged saying, well, if we can identify the embryos that are at higher or lower risk for disease, then maybe this would be useful information for couples undergoing IVF who want to select an embryo that has the lowest risk of certain diseases. Theoretically, this should be possible. And so, as I said, this is an emerging industry. There's a handful of companies that have already been founded and that are operating that will genotype and create the polygenic scores for various diseases and traits, and allow couples to then select among the embryos based on the disease risk, based on the information in a polygenic score. So these are two examples of companies like this. This is unsurprisingly a very controversial practice. So the MIT Technology Review called it the world's first Gattaca baby test. There's been a lot of talk about, does this produce designer children? And so, there's a lot of discussion about whether or not this kind of service should even be available to people. So to kind of guide my talk and talk about some of the issues underlying, why embryo selection may or may not be a good idea, I want to start with a hypothetical example from the blog of Steve Hsu. Steve Hsu is the founder of one company that offers embryo selection. In his blog, he said, consider that there's a couple who are undergoing IVF, and through IVF, they produce 2 embryos. They're visually identical. They appear to be equally viable. There's no reason just visually why we might expect one embryo to be more likely to result in a successful birth than the other. And then he said, well, here's this paper that came out in 2018 where they created a polygenic score for educational attainment. And in this paper, they split their sample into the bottom 20% of individuals who have the lowest educational attainment polygenic score, and the top 20% of individuals with educational attainment polygenic scores. And he looked at the fraction, in this paper, they looked at the fraction of people who have completed college in the different quintiles of polygenic score risk. And they find that that there's a 35 to 50 percentage point difference between the lowest and highest risk for polygenic score quintiles in terms of likelihood of completing college. And so, Steve Shu ends his blog post by asking a somewhat provocative question, knowing that there are such big differences in risk between the highest and lowest quintiles of genetic risk for educational attainment, what should you tell the parents here? Should you advise them to, genotype and select the embryos based on this information that we know from external research? The point that I want to make is that it's actually much more complicated, and that hypotheticals like this are a bit misleading in what the value of embryo selection might actually be, and that the benefits, the limitations, and risk of novel reproductive technologies like embryo selection using polygenic scores need to be clearly communicated to potential consumers. And so we wrote a paper trying to describe some of the risks and limitations and difficulties to communicating the value of using polygenic scores for embryo selection. In this talk, I'm only going to go through some of them. You can find the paper online. It was published in the New England Journal of Medicine. It has the same title as the title of this talk. But to give an overview of what we did is we performed a handful of simulations based on current information about how well polygenic scores predict different diseases and traits. And we did a bunch of simulations to evaluate what the expected benefits and risks might be to using polygenic scores to select embryos. We did two sets of simulations. One is on a continuous outcome, specifically educational attainment. What might you expect the gains in education to be if you selected embryos purely on choosing the one that was most likely to go farthest in school based on the polygenic score for educational attainment. But we also looked at a number of clinical outcomes, since this is currently the services that are offered. As far as I'm aware, I don't know of companies that are offering embryo selection for traits like education, but there are companies that are offering selection based on certain clinical outcomes. To describe the simulation framework, what we did is we just, in the simulation, we assumed that parents are able to produce 10 viable embryos. This might be much larger than some couples actually receive, especially if they're doing IVF due to fertility reasons. Some would have much fewer than 10 to choose from. However, under some circumstances, you can get more than 10. So we chose 10 just as a baseline for the simulation. But you should think if a couple produces fewer embryos, then the gains of embryo selection using polygenic scores is going to be smaller. If they produce more embryos, then the expected gains or risk reduction will be larger. And in the simulation, we said, okay, let's pretend that they choose one of these embryos at random, which is maybe based on current practices. If you have 10 embryos that seem equally viable, then I think current practice is to effectively choose at random. But then we also could identify in our simulation the embryo who has the highest polygenic score for whatever disease that we're considering. And then we simulate, like was mentioned in the very first talk of this session, polygenic scores do not determine whether or not you're going to develop a disease. It's about probabilities. And so even if you select the embryo with the lowest risk of having a certain disease, there's still some chance that they might develop that disease. And so in the simulation, we say, okay, based on what our knowledge is of the risk of disease for certain levels of polygenic scores, we'll simulate what the outcome would have been for the child if that embryo had been chosen, both for the random embryo and for the one with the highest or lowest polygenic score. And then we do this 100,000 times. Because this is simulated data and not real data, we can do this as many times as we like. So we do this for 100,000 parent pairs. I'm going to now go through and describe a bunch of the results that are considerations that need to be clearly communicated to potential consumers who are interested in potentially adopting this service. And the first and possibly most important consideration is that the expected gains of embryo selection using polygenic scores are currently the greatest for individuals with European ancestries. And the reason this is because the vast majority of genetics research that's done today is done in individuals with European ancestries. And so the polygenic score technology has advanced the farthest for this group of individuals. And generally, these polygenic scores don't generalize to other populations. And so as a result, in our simulation, predicting what the gains of embryo selection would be for educational attainment if someone used current polygenic score technology to select embryos that are most likely to go farthest in school, we see that the gains are largest for people with European ancestries and are smaller for individuals with Hispanic Latino ancestries, East Asian ancestries, and smallest for those with African ancestries. And so there are some inequality considerations about who benefits most from this technology, and a couple who maybe has non-European ancestries should know that, that the expected gains of using a technology like this is going to be much lower than might be available to couples with European ancestries. Next is that there's a lot of unknown risks to this technology, and when you select for one thing, you may accidentally be selecting for something that you don't intend to, because genes have many different functions. So you can't just select for, say, educational attainment. The genes that seem to be associated with education are also associated with a number of other outcomes that we may or may not be interested in obtaining as well. And so for example, there's a genetic correlation between education and bipolar disorder, meaning that genes that increase education risk tend to also increase risk of bipolar disorder. And so we calculate in our paper that, based on what we know of the combined risk of bipolar disorder and educational attainment, if a couple decided to select embryos using the educational attainment polygenic score in hopes of having a child who's most likely to go farthest in school, it also increases the risk of bipolar disorder in their child by 16%. So from a 1% risk in the general population to a 1.16% risk in the selected embryo. And so these are just the things that we know about. So much is still unknown about the relationship, the polygenic relationship between complex diseases. So there's a lot of uncertainty and risk, and I think this uncertainty and risk needs to also be communicated to parents, that there are certain things that may be dragged along if they're trying to select for one thing that they may not want dragged along, and we just don't know. Another important factor is that the expected reduction in risk is going to vary by risk level. So I've moved on to thinking about clinical outcomes. In this case, I'm looking at coronary artery disease. And so for someone who is just an average person, so the US lifetime risk of coronary artery disease is about 7%. And so an average person drawn from the population, if we use current polygenic scores for coronary artery disease, and tried to select the one who has the lowest risk of coronary artery disease, then we can reduce the risk of an average person by about 1 percentage point, so from 7% down to 6%. However, the gains depend a lot on what the individual's baseline risk is. And so if you're from an area with access to good healthcare, and maybe from a family who creates an environment, develops healthy lifestyles, and so your baseline risk for such a family might be lower, then the risk reduction due to embryo selection is even smaller. And so you might only reduce your risk of developing coronary artery disease by 0.5 percentage point. On the other hand, if you're from a high-risk family, then the the potential reductions in risk using a technology like this might be a little greater. I also want to highlight again that the concerns that I brought up about how this primarily being beneficial to individuals with European ancestry applies here even in clinical traits. And so, I'm going to show the results, for the next few slides corresponding to individuals with European ancestries, because this corresponds, to the very best that these technologies could possibly do. It's important to keep in mind that in practice, the actual risk reductions is going to be smaller than these numbers that I'm reporting. So another thing to keep in mind is that the expected gains vary a lot by phenotype, and so or by disease. And so here's what the risk reduction looks like for coronary artery disease. We're seeing reductions in risk of about 1 percentage point, plus or minus a little bit depending on what the risk in the family is. For something like type 2 diabetes, the reduction in risk is something closer to 5 percentage points. That said, the prevalence of type 2 diabetes is also very high. And so, going from a 35% chance of developing diabetes to a 30% chance, I don't know if people would consider that a lot or a little, but the fact that you're going to get different returns depending on what phenotypes you're interested in trying to reduce the risk of also needs to be communicated to potential consumers. The last point that I want to make is that there are different ways to communicate the performance of embryo selection and how much the risk can be reduced. And so take, for example, the phenotype of idiopathic short stature. And so these are this is trait where where your height is 2 standard deviations below the mean. And so so it's sort of rare, but these are people who are very, very, very short. Now, if we wanted to use the height polygenic score to select an embryo who is less likely to have idiopathic short stature, you're able to reduce the risk of idiopathic short stature by 1.5 percentage points. And so this feels like a very small amount, and maybe a person who's concerned about this may choose not to spend the money on a service like this if they're told that they would only be able to reduce the risk of idiopathic short stature by 1.5 percentage points. However, if you instead reported this as a relative risk reduction, so what's the percent? We notice here that only slightly greater than 2% of the population has idiopathic short stature, and so reducing the risk of that by 1.5% means large reductions in relative risk. Meaning you could reduce the risk of idiopathic short stature by almost 80% if you used embryo selection. And so these two numbers are using the same data, the same results. They're both true, but they presented in a way that I think is it tells a very different story to a potential consumer. In the paper, we advise that companies who are offering a service like this should focus on the absolute risk reduction, because relative risk reduction can lead to people having an exaggerated sense of what the benefits of services like these are. But minimally, companies who are offering a service like this should report both the absolute and the relative risk reduction if they want to communicate the actual potential benefits of embryo selection responsibly. So just to summarize the points that I just made, if potential consumers of embryo selection need to understand that the gains of embryo selection differ by the parent's ancestry. It varies by the risk level that the family has for the diseases that they're considering, and it varies also by the outcome or disease that is being selected against. The second thing is that the risks of embryo selection are unknown. It's a very new technology, and there may be risks that we're just unaware of that we're imposing on children who are born using a technology like this, and we just know very little currently. And finally, reporting results in terms of relative risk reduction can be misleading, and so we recommend that companies who are offering a service like this report their potential benefits in terms of absolute risk reduction. Overall, the point that I'd like to make is that new genetic tools like embryo selection using polygenic scores are very complicated. They have complicated risks and benefits, and they need to be broadly studied and discussed. I've only listed a handful of the other concerns, but there's also a number of other reasons that a technology like this is potentially risky, both societally and individually, to potential consumers. I finally just wanted to thank all of my co-authors on this paper. This was a big joint work with a lot of individuals who the work wouldn't have been possible without all their help. So thanks to the co-authors for the study as well. So those are all of my slides. So I am available for questions if people have any questions for me.